right. Hi, everybody. So my talk's going to be on LedgeRidge. Here's the organization of the talk. It's going to be a little more technical in terms of the geology and the geochemistry. But at the end, I promise I'll get back to the questions that we really want to address in this session. For those of you who don't know where LedgeRidge is, it's very close to the New Hampshire and Quebec border. It's in Maine, northwestern, or we could say western Maine, really. Not too far from the Vail site. LedgeRidge is really a ridge. It's clearly visible on Google, as you can see here. Just a quick recap of the archaeological work that was done there by, of course, Mike Gramley and friends. Many of you already know most of this, so I won't go into it in detail, but there's some of the references in case you're interested in more detail. Now, Mike Gramley, with some colleagues, did first attempt to go to LedgeRidge in 1980, and they did find quite a bit of chert there, and I think that at that point, Mike realized that this was a very interesting potential source of chert. They made a second visit in August of 1984, at which time they actually even opened up a unit in front of an outcrop. They found flakes in association, direct association with the chert outcrops, and therefore, at that point, Mike Gramley suggested that there might indeed be a quarry here. Just a quote from his notes from 1985 there about what they found in the unit that they opened up. Just a couple of notes there just before I get into the technicalities of LedgeRidge and the chert is that for those of you who know, for example, the Vail site, you'll know that in the report, Mike mentions that the LedgeRidge Church dominates the Vail site assemblage, but at the same time, the Vail does have a very high tool-to-flake ratio, which is sort of unusual, of course, given that you'd be so close to a source, and that there were very few hard hammer flakes, and that they were very small flakes, and so not very large flakes, and no cores. And I think, if you read Vail in detail, you'll realize that even Mike at the time was a little perplexed by this. Here's a scan of a slide that Mike was kind enough to share with me. He sent me 4 or 5 from when they went and did some work there, and this is in 1984, so taken right there when they were trying to open up, I guess, in front of an outcrop. So a bit about the geology. Now, those of you from Maine are obviously very familiar with the Osberg map, the bedrock geology map. A couple of other references. Very little has been done on the geology of this part of Maine. Breedlove's master's at University of Maine, if you are interested, and then Bob Munch's work. And I'll show you why I think Bob Munch's work may be more useful to what I have to do. This is the Osberg map. Again, most of you know this map if you're from Maine, and what you find in this part of Maine is basically a series of unnamed metavolcanics and metasedimentary rocks dating anywhere from the Cambrian to the Ordovician to the Devonian. That's obviously just probably partly because the geologist didn't necessarily have the time to spend the time there doing detailed mapping, but also maybe because there wasn't that much economic interest. However, when Breedlove went back to do his master's, he went there because there was a massive sulfide deposit, and massive sulfide deposits usually associated with metallogenic deposits, which do have a very high economic value. Now, Bob Munch went back. He's more of a structural geologist, does tectonics, and they mapped this area in more detail. And so what you'll notice is there is actually already quite a big difference in where the LedgeRidge falls in terms of this map as opposed to the previous Osberg map. Just a quote here from the report that accompanies the map. You can all get this from the USGS. It basically refers to a series of tufaceous metasiltstones. There's rhyolite ash. That's interesting for those of you who were with us in New York a couple of weeks ago, because rhyolite ash is a good source of silica. You can usually make chert out of that. But there's also mention directly at the end there of ferruginous chert. in this formation, the one that's indicated here as DP right there. And I'll just focus in a little bit on that area of the map. And you can see here that LedgeRidge really is right in the green formation there. It's in the green formation that's actually named here SRWV, and not actually in the DP, which is the iron-bound mountain formation. And it's actually right at a fault. The major fault is actually the Thrasher Peaks Fault, but there's another smaller fault, a minor fault here called Deer Pond Fault. And Deer Pond Fault is in fact what makes LedgeRidge. That's why LedgeRidge is a ridge. So what we're looking at actually, if we go with with Bob Munch's work and not with the Osberg map, is that the LedgeRidge chert is in basically the same thing, metavolcanic, metasedimentary rocks, but here in this case Silurian. And more importantly for us, it's that it's very closely related to a fault setting. What did we do there in terms of the geoarchaeological work? Well, we went there in 2009. Couldn't have done it without Kenny Wing and especially Charlie Adkins and of course Mike Gramley's notes. We took some samples along LedgeRidge. This is just the GIS data and the GPS data. And just to point out that if we zoom in, the bedrock geology map here is based on the Osberg map, so we're actually in the different formation than the Munch map, but that doesn't matter. So we collected along the ridge in 32 locations. That's multiple samples in 32 different locations. This is what it looks like. This is at the waterfall. It's a very nice place. And if you zoom in, just sort of look over at this and more specifically this. As we zoom in, you can see that's the chert there. Now it can be pretty good quality. It does have some jointing, which is going to affect its nappability, but also the way you extract it. You can get big blocks out of there. I bought a couple of samples if you want to see just sort of the colors and the variability and the sort of the fine-grained texture of it. So you can get big blocks of it and large tabular blocks, which is interesting for flint knappers and obviously for Paleo Indians. So what did we do in terms of the geochemistry? Now, this is the sort of the nitty-gritty. We have many samples that we cut and polished. So this is, I'm only going to talk about the samples that we collected. But Mike Gramley gave you some of his, and then we took one sample also for the Maine State Museum. But I'll only talk about the samples that I collected in situ. These are cut and polished samples of the cherts. So if we look at the geochemistry, what do we see? Well, LedgeRidge chert is a chert. That's already interesting, because at first I wasn't sure if it might not have some kind of igneous signature in it, being associated with massive sulfide deposits, hydrothermalism. It's in a setting, basically an igneous rock setting. So, but it's a chert. It's a highly siliceous chert, actually. But it is highly variable geochemically. Now, that's not surprising for those of you who know about chert geochemistry, but it's actually more variable than what I'm used to, even for like Hudson Valley cherts and stuff. So it's surprisingly, because remember, we only sampled about within 2 kilometers of a formation that's, you know, not huge. The ridge isn't huge. So, I mean, that's 32 samples and not in a big area. So this is just a ternary map, so just showing you silica, iron, and aluminum. Just a couple of other maps with light rare earths and barium, just to show you that there's quite a bit of variability just within those samples geochemically. And in fact, when we looked at it more carefully, we actually saw 4 different groups geochemically, which is kind of surprising and sort of bad news for people who want to do sourcing. All right, so what do we do with that? Well, obviously, you know, what I want to do is connect it to archaeological samples. So we did all our homework, geological homework, did all the geochemistry. I think we have enough samples to say that we have an idea at least of what that ridge, the chert from that ridge is supposed to look like. Again, Mike Ramley was kind enough to lend us this scraper that refits onto a kind of a core, or originally a side scraper from Upper Wheeler Dam. It was a great match for LedgeRidge chert. I mean, anybody would grab that and compare it to our hand samples would say this is the same material. And Upper Wheeler Dam is only 13 kilometers from LedgeRidge. I mean, it's basically next door. So there was good reason to believe it was LedgeRidge. The scraper, by the way, there's a really nice drawing of it in an article in ANA that was published a while ago. And that scraper and the core or side scraper fragment that it refits to is clearly a chert, right? I mean, that's not a problem. It matches other cherts that we have. There they are up there in the circle. The bad news is, though, that while sometimes it matches in some elements, like silicon and calcium, that doesn't really mean much. What you want to look at is stuff that's not as common, like barium or titanium, and there it's completely off. It doesn't match it at all. And I'm sorry about this slide. Believe me, it actually means something to me, but it doesn't have to mean anything to you. It's a spider diagram, and just focus on the light blue there, those two samples from Upper Wheeler Dam, and they're just not even matching any of the groups of LedgeRidge, unfortunately. So we went back into our database and we said, well, what could it match maybe? And well, we said, well, maybe we should compare it to like West Athens Hill, because we have tons of samples from West Athens Hill, archaeological, geological, any kind you want. And it's a very good match, actually. It's pretty close, actually. And you'll notice it's tighter. West Athens Hill is tighter also in terms of the geochemistry and the spider diagram. So, I mean, if I were to guess, I'd say those two artifacts didn't come from LedgeRidge. They probably came from the Hudson Valley. What else have we done since then? To be honest, we haven't done a lot of sites from the area. We've been focused on other questions like, is there New York chert in sites like Vail or Michaud? And for example, our initial answers are that there's some Hudson Valley cherts at Vail. The samples we ran from Michaud, they turned out to be not chert. They were all rhyolites, the 5 artifacts that were sent to us. But we've actually ran several samples, archaeological artifacts from Clichy-Rancourt, just across the border, 59 of them, and we haven't found a single match for LedgeRidge. And why is that surprising? Well, because Clichy-Rancourt is right next to LedgeRidge. I mean, it's really close. I mean, it's basically as close as Vail is. And in fact, out of those 59 artifacts that we ran, I chose several that I thought were pretty good matches for LedgeRidge, as weathered, some kind of weathered fine grain, light green, sort of chartreuse sometimes materials. So in terms of those 59 samples, I was kind of surprised that there wasn't any material from LedgeRidge, given that we were so close. In fact, what shows up at Clichy-Rancourt is sort of what's in a star here. That's confirmed at Clichy-Rancourt. And there's only one source that we're not sure about, the square, and then what is in the triangle is stuff that we tested that we thought would be present that is absolutely not present out of 59 samples. Obviously, we didn't do thousands, but 59 is not bad for a Paleo-Indian site. And so if you kind of look at the minimal territory just for Clichy-Rancourt, and this is going to be published in Archaeology of Eastern North America soon, I hope. I don't know where Art is, but he'll tell you when it'll be coming out. This would be the minimum sort of range for the materials that are confirmed at Clichy-Rancourt right now. So to get to kind of the point of this session, which is colonization of the far northeast, and in my case, obviously, what the role of these raw materials might be. As you've already seen, raw materials figured prominently in the first 2 talks. Mike Ramley obviously thought that they were important right from the beginning, and I think in most Paleo-Indian studies you'll see this. Often raw materials have a pride of place, I would say, even in Paleo-Indian studies. And at the time, this is a long quote, but just for example, for the Adkins site, there was already some questioning as to why is it so different between Vail and Adkins? Is it change in time? Why would you be sort of in one case dominated by LedgeRidge and another case not, sites that are just right next to each other? I'll let you read this maybe 30 seconds longer. I'm not necessarily going to address those questions directly because I'm here just to furnish the raw data that then you can use to make up your models that you can test. But it is interesting that, for example, even in this map already from the Adkins report, I think this is Adkins, yeah, Mike was already pointing to the fact that some sites were dominated by sources from the north, like Ledge and other sites were dominated by sources like Munsungan, and other sites dominated by sources that were maybe further to the south, like, for example, this possible New Hampshire rhyolite. But it's not Jefferson rhyolite, by the way. And so it's interesting that already, you know, this was an issue, but at the same time, it wasn't clear how to resolve those questions. How is it that you can have such disparate proportions even among sites that are close to each other? And in some cases, maybe a question of time, like we just heard, maybe and Nathaniel was mentioning, might be a question of simply of time. And obviously, these raw material sources are then come into play as major players in terms of the larger models of sort of groups moving around the landscape. And again, this is from the Vail report, and Mike had proposed two different models, and as you can see in both, you have the number 3 circle, that empty circle, is the raw material source, and in both cases, we see that the raw material sources are meant to be, you know, important sort of markers, fixed resources on the landscape that may have may have a very important role to play in terms of the larger peopling of the region. Now, I'll just leave it at that. I'll just, to conclude though, however, obviously now we have to reconsider the role of LedgeRidge. That's obvious. We have to do more, but it is highly variable in its geochemistry, even within the 2 kilometers that we sampled. That's not unusual for cherts, but it is still quite variable, even more variable than I would have expected. It makes it quite hard to match it to specific artifacts, and this is even worse, obviously, if they're weathered, which is often the case with the Paleo-Indian materials. Good news, if there's any good news to come out of this, is that we can tell if something's not LedgeRidge. I think that's good. Yeah, there's some good news in this. And obviously, it would be better if we did a systematic sampling of some of these sites based more on the questions that you have. If things are identified as LedgeRidge, that we could then compare to our database. But all I can promise you is I can tell you that if they're not from LedgeRidge, but maybe we'll be lucky and actually this time choose some that actually match LedgeRidge, which is entirely possible. That's it.